Hello students, welcome to online class. Today I am going to explain the determination of specific charge of an electron. In previous class we discussed about principle and the experimental arrangement to determine the specific charge of an electron. You know that in this experiment, the electron being first subjected to known electric field and the corresponding deflection is measured. Next, a suitable magnetic field is applied such that the deflection of the electron due to electric field is nullified by it. By knowing the value of the field strength and the deflection, we can determine E by m of electron. In the absence of any field, the cathode ray or electron that is coming out from the cathode, it reaches the point O on the screen. Now we can apply a electric field between the two plates P1 and P2 at the instant when the cathode ray enter the region between the plate P1 and P2. Initial velocity in the downward direction is 0. As soon as the cathode ray enter the electric field between the two plates P1 and P2, the electron or cathode ray experience a force and it is given by F is equal to E into E. From Newton's second law, we know that the force is equal to mass into acceleration. When we compare these two equations, we can get A is equal to EE by m. Here A is acceleration acquired by the electron as soon it enter to the electric field. E is charge of an electron, m mass of an electron, E is the applied electric field strength. The distance traveled by the particle towards the plate is given by y dash is equal to half at square. That is because we know that from the equation of motion S is equal to ut plus half at square. In this equation, S is distance traveled, u is initial velocity, a is acceleration, t is time taken. In this experiment, the distance traveled is taken as y dash and initial velocity is 0. Therefore, that equation becomes y dash is equal to half at square. Now, substitute the value of a in this equation, we get half into EE by m into t square. Call it as equation number 2. The time for which electron move in the electric field is given by T is equal to L by V, where L is the length of either of the plate and V is velocity of electron. Substituting the value of T in equation 2, we get y dash is equal to half into EE by m into L by V whole square. Call it as equation number 3. With the given electric field between the plate P1 and P2, now we can apply the uniform magnetic field in the perpendicular direction to the electric field. In this case, the cathode ray or electron, it experiences a force that equal to BE into V and which act in the upward direction. Now we can adjust the magnetic field until the net deflection of bright spot is zero. This is because when we applied the electric field, so it produces the deflection in the downward direction. When we applied a magnetic field perpendicular to the direction of an electric field, so this cathode ray experiences the force in the upward direction. So the deflection produced by the electric field is balanced or nullified by the deflection produced by the magnetic field. Therefore, at equilibrium, electric force is equal to magnetic force, hence EE is equal to EVB. So here EE get cancelled. Therefore, V is equal to E by B. Call it as equation number 4. Substitute the value of V in equation 3. We get Y dash is equal to half into EE by M into LB by E whole square. And simplifying the above equation, we get E by M is equal to 2Y dash E by B square into L square. If V is the potential difference between the two plates P1 and P2 and D is distance between them, then E is equal to V by D. So we know that electric field is equal to negative potential gradient. So therefore E is equal to V by D. So substitute the value of E in this equation. We get E by M is equal to 2Y dash V by DB square into L square. Now the total deflection is given by Y is equal to Ky dash, where K is constant determined by the geometry of the discharge tube. Substitute the value of Y dash, we get Y is equal to K into half EE by M into LB by E whole square. Then the E by M is equal to 2YE by K into L square B square. By knowing the value of L, B and Y, we can determine the E by M of electron. The experimentally E by M of electron is found to be 1.7597 into 10 to the power minus 11 coulomb per kg. Thank you.